Welcome to the Crazy Hat Chemist. So today we're doing the 19th video on nuclear chemistry, so let's get started. BAM! Today we're going to be doing some dating, but it will be radioactive dating, so that should be even more fun than regular dating. So, a useful application of radioactive dating decay is the determination of the ages of substances, whatever it is, and we use this all the time. For living systems, the ratio of carbon-14 to carbon-12 is the same as the atmospheric ratio, because there's a constant interaction and exchange with the environment. However, when that organism dies, whatever it is, whether it's a woolly mammoth or a tree, this interaction stops. And the carbon-14 starts decaying. Its half-life, as we had mentioned numerous times in these series of videos, is 5,730 years. Carbon-14 decays via a beta pathway to nitrogen-14. So if you compare the relative amounts of carbon-14 to carbon-12 in a sample, that remains allows the age of that organism to be established to a great degree of certainty. So there are many other applications, and you can use any different types of radioactive dating as well. It doesn't have to be the carbon-14. It could be various different other isotopes depending on the age of that substance. We're looking for something that really works well with the half-lives given. Okay, but for living organisms, carbon-14 works really nicely because its half-life is 5,730 years. So, let's do an example of this. A tooth was discovered on Rio's campus at the building site in 1963. If only 3.125% of the initial amount of carbon-14, that's the half-life of carbon-14, is 5,730 years. If only 3.125% remained, how old was the tooth? All right, so let's figure this out. Okay, we have actually used this equation on a previous one. That is 1/2 to the power of the number of half-lives times the original amount is equal to the amount remaining. So, how much remains? The amount that remains is 3.125%. How much was the original in terms of percentage? 100%. So hopefully that makes sense. The 1/2 there is a constant, but we don't know the number of half-lives. So we need to figure out the number of half-lives. So we're going to plug this in here just like this. So we got 1/2 to the power of x times 100, that's 100%, because that's the original amount, okay, equals 3.125%. That's how much remains, okay? So what we're going to do is we're going to divide by 100 on both sides, and then we're going to do that log base 10 thing that we did on a previous slide. So we're dividing both by 100 to move that 100 onto the other side because we are solving for x, and then log base 10. And there's a rule with the log base 10 with that little x there as a power because we want to bring that x over in front of the log base 10, and there's the rule on that right there. So what we're going to do is we're going to bring that x as a power up to in front of the log base 10. There's the rule in the yellow and the purple. Okay, so there's that right there. I brought the x in the front. Now what we're doing, as like what we were doing before, is we're still solving for x. So we're going to divide both sides by log base 10 to the 1/2. So we're going to divide both sides by that. Okay, log base 10, log base 10, 0.03125 divided by log base 10 to the 1/2. Divide those answers, and then this is what we're going to get. We're going to get 5. And remember, we're solving for x, and x was the number of half-lives. So this tells us that we have 5 half-lives that has passed through this amount of time. So since we already know the half-life of carbon-14, that's 5,730 years, we're going to take the number of half-lives and the half-lives, the number of half-lives, that's 5, times the amount of time, which is a half-life, 5,730 years, and multiply them, and then that will give us our age of our tooth. So 5 times 5,730 gives us the age of our tooth. Our tooth is 28,650 years old. Okay? All right, that's when that tooth died, or the organism of which had that tooth died, if you will. Okay? That is another awesome video from the Crazy Hat Chemist, and if you figure out what this is, what kind of animal, what kind of creature here, okay, I graduated from this college. Well, one of the colleges that I graduated from, rather. Give me a thumbs up if you like that video, and subscribe to my YouTube channel, please. Thank you very much. Bye now.